Hello, so to try and understand radiation and temperature, we're going to look at Bob and his not so frozen chicken. Now Bob one day went to the beach, nothing wrong with that, and you can see him there sunbathing on his towel, and he's taking his frozen chicken with him, and he put it that's next to him on his frozen chicken, and obviously this is not going to end well. He's on the beach, it's a lovely sunny day, so let's have a little look at the frozen chicken in a bit more detail in terms of radiation. So if we have that as the frozen chicken, FC for short, we can look at the radiation coming in from the sun, perhaps most of it infrared. Obviously there's a little bit of visible as well, and let's say that the incoming radiation has a total power of 200 watts. That just means 200 joules per second of incoming radiation. So that's great. It's going to have a bit of an effect, isn't it? The frozen chicken does give out some radiation. You might not realise it because it obviously is frozen, but it will be emitting a little bit of radiation, especially as it starts to warm up, but it's going to be much less than it's receiving. So we've got it emitting, let's go for 20 watts. Obviously I'm just making these numbers up, but it doesn't matter because it's what happens if we know the information that matters. Well, if we look at that, that's the irradiation being emitted. Not sure if it's 1 or 2 T's, unfortunately. You can look that up for yourself. That's the emitted radiation. So in terms of the frozen chicken, its temperature starts to go up. It's gaining 180 more watts of radiation than it's losing, so it's a net gain of energy, it's an overall gain. So we can say the temperature of the chicken increases. Temperature of the chicken increases, and because energy in is bigger than the energy out. Let's go for a bit of mathematical. Okay, and obviously that means the frozen chicken is going to melt. Not good for Bob. A significant chance of catching salmonella if he then eats the chicken later. Now Bob is not daft. He goes back to the beach the next day, and this time he takes his chicken shading tent with him. You can work out for yourself why Bob has turned red, if in fact that is red, but it's to do with the day before spending too much time in the sunshine. But anyway, back to the physics. Let's look at the physics. Let's look at the frozen chicken this time. So there's our little FC, frozen chicken, and now we've got the situation where the incoming radiation is the same. We're going to pretend it's the same amount of sunshine. Nice warm sunny spell, 200 watts coming in. But this time we've got the shade of the tent. So actually the radiation going into the frozen chicken drops. And maybe this time it drops to 20 watts into the chicken, because of the chicken shading tent that Bob bought. So there's only 20 watts into the chicken, and let's pretend that the 20 watts the chicken gives out stays the same. 20 watts out from the chicken, meaning that 20 watts in, 20 watts out, we've got a situation where the energy in is equal to the energy out. And so therefore, well, there's no overall change in temperature. Every time he gains energy, he's losing the same amount of energy. So it shouldn't perhaps be a surprise that the temperature of the chicken remains the same. So it remains frozen. It remains the same. So there is your important equation, and there's your other important equation, and I think it's pretty much saying a little bit of common sense. If the energy in is bigger than the energy out, the temperature of the object will go up. If the energy in is equal to the energy that's being lost, then the temperature of the chicken or any object will remain the same. Okay, so one last thing, I want you to have a little think about what would happen in this situation. So let's go and put the frozen chicken from day 1 back in the freezer, and this time let's say it's losing, let's stick with 20 watts, and this time it's not receiving any radiation. So what's going to happen then? So energy out is greater than the energy in. The chicken cools down, i.e. temperature reduces. Okay, so no radiation into the chicken. Now this is a big simplification, there's lots more going on in real physics, but this topic I just want you to get this key idea about what happens to do with the radiation going into an object, the radiation going out, and 3 cases. If the radiation is the same, the temperature will stay the same. If the energy leaving is bigger than the energy going in, then the object will cool down, and if the energy going in is bigger than the energy leaving, the top one, look, energy in is greater than energy out, then the temperature will increase. Okay, thanks for listening.